Hi everybody. I wanted to first review with you the phase changes that we went over Tuesday. So I'm going to go over all 6 and then we will dive into the next topic, which is phase diagrams. So let's start with phase changes that require energy. So melting. Melting requires energy because we're moving from solid to liquid. So those molecules in the solid are going to be absorbing energy, heat energy, and that kind of breaks those molecules up and they can move more freely around each other, which is the liquid phase. Then we've got vaporization, which is when that liquid absorbs more heat energy and it can overcome atmospheric pressure, and the liquid will vaporize and we will have the gaseous state. Or the last one that requires energy is sublimation. Sublimation is really cool because it's when the temperatures are so high that the solid will just skip the liquid phase and go straight to gaseous. And the example of that there is dry ice. Now let's talk about phase changes that release energy. So we've got freezing, which is when a liquid becomes a solid. So the liquid is losing heat energy and those molecules are getting slower and slower and slower until eventually they're just they're not completely still, but they're moving a lot less than when they were liquid. Then we've got condensation. That is when a gas loses enough heat energy that those molecules come together and form liquid. So dewdrops or rain is another example of condensation in the atmosphere. You've got water molecules that will lose so much heat energy because the temperature is dropping that they condense and they fall out of the sky. And deposition is when we go straight from a gas to a solid, and that is when temperatures are cold enough that that gas crystallizes. So examples of that would be snowflakes or frost on your car. So the water loses temperature so fast, we've got such an extreme temperature drop that it skips the liquid phase altogether, kind of the opposite of sublimation. So those are the phase changes that require and release energy. Today we are going to talk about phase diagrams. So phase diagrams are diagrams that show us the 2 factors that affect what phase a substance is in. We've got the 2 factors, which are temperature and pressure. So temperature and pressure can have opposing effects. So an increase in temperature will usually cause melting or vaporization, whereas an increase in pressure might cause condensation or freezing. So a phase diagram is going to compare these 2 and show us where a substance will be a solid, a liquid, or a gas under those different circumstances. So you've got 3 regions, which stand for the 3 phases on this graph: solid, liquid, and gas. The 3 curves separate the different regions, the area where 2 phases of water can exist. So the yellow curve represents ice and vapor. The blue curve represents liquid and vapor. And the red curve represents liquid and ice. And then where these lines meet, where the curves meet in the middle, is called the triple point. And in the triple point, all 3 can exist. So all 6 phase changes can occur. We can have freezing and melting at the triple point, we can have evaporation and condensation at the triple point, and we can have sublimation and deposition at the triple point. The other point on the phase change diagram that I would like to talk about is the critical point. And this is the point at which water can no longer exist as a liquid. If water is at the critical temperature, an increase in pressure will not change it back to a liquid. It is in gaseous state, it's going to stay there no matter what the pressure is. So different substances are going to have different phase diagrams. So the one for water is not going to look like the one for carbon dioxide. So the last one I want to show you is kind of cool because it's showing you the phase diagram of carbon. So there are two materials that I'm sure you are familiar with that both contain carbon. One of them is graphite, like in your pencil, and the other is diamonds. So when carbon is at low pressures, we've got carbon existing in sheets. And when you write with your pencil, these sheets are what come off on the paper. They slough off of the pencil and they're left on your paper. But if we put carbon under enough pressure, that's going to change. Those sheets are going to become a more geometric shape, and the atoms bond together in a different way because of the pressure change, and that creates diamonds. So graphite, super soft, you can write with it. You can't write with a diamond, but they're made of the same thing. So that's the difference. That's a really cool difference that you can see in just one element. And you can see it on the phase change diagram. At lower pressures we have graphite, at higher pressures we have diamonds. So that is it for today. So I hope you guys have a great day and enjoy this beautiful weather, and I hope you guys have a great weekend as well. Bye.